In this video, we're going to be using MGF to find the mean and the variance of a binomial. So first thing we want to know is that when we talk about MGF, we have m sub x of t is equal to the expectation of e raised to the power of tx. And what we are interested in basically is the mean. Here, the mean is the first derivative of this mx to t. Meanwhile, we take t to 0, right? Remember that the expectation of x for any discrete random variable is summation of n starting from 1 to n of x, then the PDF. So in this case, the PDF or the p of x of a binomial distribution is n combination x, p raised to the power of x, q raised to the power of n minus x. So if the expectation here, we now have expectation of e raised to the power of tx, it means that we are going to be having the summation of e of tx then p of x, since we are replacing x here with e tx. So let's go ahead to put all of this together. Now our m of x t will now be the expectation, which is now in turn the summation from 0 to n of n combination x, e t of x, then p of x, q n minus x. So we can categorize all of this to be m of x to t before we even think of putting the 0. So this will be summation from 0 to n, then n combination x of e t p all together with x, because they both have power of x, then q n minus x. So we can make this a little bit easy by recalling that from our binomial theorem, that a plus b to the power of n is the same thing as the summation to n of n to r, a raised to the power of r, b raised to the power of n minus r. Looking at this, comparing these two things together, we can see that this is this here. A is like our ETP and our Q is B. So which means that our m of x of t is the same thing as writing ETP plus Q raised to the power of n. Then we can go ahead to follow this, taking t to be, but we need to take the derivative, the first derivative, to get the mean. So I'll take the first derivative of this, still t, then using my function of function, n comes down here, then that is ETP, then I have e raised to the power of t p plus q, then I'll take one out of the power. Then let's go ahead to make t0 from the requirement of the mean. That would be n e raised to the power of 0p, e raised to the power of 0p plus q n minus 1. Okay, let's take this out. So in essence, the mean will now be np into p plus q raised to the power of n minus 1. So remember, from the property of probability, that p plus q is equals to 1, so I can rewrite the mean to be np into 1 raised to the power of n minus 1, and of course that will be np. That's definitely the mean of a binomial distribution. So let's go ahead to find the variance of the binomial distribution. Knowing fully well that the first derivative is still here, then let's take this out. So we can make use of this subsequently. Now remember that the variance using MGF is the second derivative. Now we take t to be 0 as well, then we subtract it from the mean we've gotten by squaring it. We already have the first derivative here with respect to t to be equal to n etp into etp plus q raised to the power of n minus 1. So we'll go ahead to do the second derivative of this. And that would exactly be second derivative of x with respect to t. We use our product rule. So let's take this part first, then we ignore this other part using product rule. So if I should differentiate the first part, that will still remain the same because it's an exponential function. So I'll rewrite the second one plus q n minus 1. Then plus, rewrite the first one, then differentiate the second. If I should differentiate the second, then n minus 1 comes down. Differentiate the inner part, which is etp. Then I'll remove 1 from the power, which is plus q n minus 2. Now this is the second derivative. So all I have to do now is to substitute 0 for t. So second derivative here, but t is equals to 0. That will be ne0p e0p plus q n minus 1 plus n0p n minus 1 here e0p, then e0p plus q n minus 2. So e raised to the power of 0 is 1, that is np, and we still have p plus q here, n minus 1. Now this is going to be 1 here, and this is going to be 1. So we have p in two places. That will be np squared, then n minus 1, then p plus q, n raised to the power of minus 2. Raised to the power of n minus 2. Then we've said that n plus p plus q is 1, so 1 raised to the power of n minus 1 is still 1. So I would have here np plus np squared into n minus 1. So I'll go ahead to fix that into this major formula here. Then we would have the variance should be np plus, open the bracket, that will be n squared p squared minus np squared, then minus this mean here. So the mean that we got is np, then take the square of that. That would be np plus n squared p squared minus np squared minus n squared p squared. This cancels this out. Then I have the next one to be np minus np squared. This is our variance here. So I see that np is common between the both of them, so I'll bring it out. So I have 1 minus p. Remember that p plus q is 1, which means that q is 1 minus p, right? Then take the variance here. That will be npq. And that's how to find the variance of a binomial distribution using MGF. Very easy. Don't forget to like, share, and also subscribe to this channel so you can see more videos of this type subsequently. I'll see you in the next one. Bye for now.